Thank you. So I'm going to talk a little bit about code. We say infrastructure is code all the time. It's in pretty much every talk here every year. But we don't really get a lot into what code really means in that context. It can mean a wide variety of things and probably mean something different to everyone. So I want to try and break that down a little bit. Code can be snippets, kind of cargo cult programming. If you were doing any web development or anything like that in the late 90s, you might remember DHTML before HTML, way before HTML5. And you could go and copy and paste these snippets of JavaScript code into your website, and suddenly your website would move. It was very exciting. And you could get stupid stuff like eyes or more useful things like nested menus for your e-commerce website. But these were copy and paste. You just copied and pasted this chunk of JavaScript in there, and there were a few variables you could twiddle at the top, but for the most part, you just dropped it in there. We have snippets in Puppet, too. A lot of folks, developers especially, when they're using Vagrant and Puppet, for example, to do configuration of a system, and they're focused on doing development on that system, on that Vagrant box, they don't really want to learn Puppet. So they'll find GitHub sites and gists and things like that and copy and paste in enough Puppet to get the tools they want installed at the versions they want and move on. So in both of these cases, this is definitely code, but I would argue it's not programming, right? You don't really have any understanding of what's going on there or any control over the system aside from pasting things in. And in the Puppet case, it's not configuration management. It's really just a different way of spelling a shell script to do an install. So the next level up is a script. And by the way, I know these examples are very small. It's mostly because the content of them doesn't matter. The idea here is that's the whole thought. That script right there, this happens to be something which reads reports from a Puppet master and can then spool them to disk to send them to Foreman afterward. But that's a complete thought. That does everything that I need to do in that script. There's not a lot of comments because you can pretty much read the whole thing on one screen. If I needed to make some changes to that and didn't really understand how it worked, I could just throw it out and start over. It would only take me another 10 or 20 minutes longer. So there's no real need to build a lot of structure in there. But we've probably seen cases where you start out with a short script like this, and then you want to add some monitoring, and maybe you need some error handling, and oh, it needs this other feature. And it starts to get longer and longer. And I think we've probably all been through this. You get diminishing returns once you've got a certain length and complexity of your script. Making changes to it gets harder and harder. So I found a nice blog entry about this, describing something called the Norris number. And this is the average amount of code that an untrained programmer can write before he or she hits a wall. And that wall is really that diminishing return. You add a couple hundred more lines for one more feature, and then you try and add a few more lines, and you end up adding 3 bugs along with that feature, and then you're fixing those bugs. And somewhere around 1,000 lines or something, scripts really break down as a way of getting your purpose done. They're just not up to the task anymore. So I would argue this is the boundary where code and scripts become software. To get past that Norris number, that complexity level, you need to start writing software and not scripts. And what I want to talk about today is infrastructure as software, and that means writing software in Puppet. So when I bring this up, I get funny looks from people. People don't think of software or as Puppet as something you can write software in. I think Puppet's a language, just like Ruby or Python or C or Java or any of these. It's a little bit more domain specific, and Luke said in his keynote, it's not Turing complete, and it's not intended to be. But if you were at Henrik's talk yesterday, he's done a huge amount of work, and the whole Puppet team has done a huge amount of work in Puppet 4 to make it a much more reliable language. So this is a language. This is something that we can write software in. And I want to tell a little story here. I work in release engineering at Mozilla, and we mostly run machines that do build and test. So they're building and testing Firefox and Firefox OS and Firefox for Android and a couple other products. So we have very specific purpose and things that we need to do with Puppet. And there's a whole other group, the infra group at Mozilla, which does they run the systems that run Mozilla.org and websites and databases and things like that. And they have their own Puppet install. And when I explain this to folks at Mozilla, I often get puzzled looks saying, well, you have 2 Puppet instances? What the heck? Why don't you just put those together? And I think that's kind of ridiculous, right? When you think about Puppet as a programming language, so to make the comparison to Python, addons.mozilla.org is a Django site. And we have this performance testing framework called Talos that we run on our test slaves that measures the performance of Firefox. Well, they're both in Python, but it'd be ridiculous to suggest that those be the same application. They do different things. So I think this is already part of software. Software is designed to solve one problem, and how you solve that, what language you use, is sort of secondary to that. And it's very possible to have 2 different problems that can get solved with the same language and the same tool. So the tool I mentioned that release engineering uses is called Puppet again. It's a pretty cool tool. It's open source, just like if any of you saw Liz Joseph's talk yesterday. OpenStack has an open source infrastructure built in Puppet. We have a similar thing, accomplishes very different goals, but it's also open source. It's cross-platform, highly available. It's a cool tool. I'm going to be using it as an example in the rest of this talk, but I'm not going to get into hardly any of its cool details. So it's a Googleable name. There's a tiny URL there. I do encourage you to check it out. I think it's pretty cool. And maybe someday I'll talk about it in more depth. All right, so let's look at what software is. I want to talk about a few different attributes that I see in software in general, and then think about how we apply them in Puppet again, and how you could apply them in configuration management in general, in infrastructure as software. And the first of those is an architectural model. I think this is probably the biggest part of getting past that Norris number limit and writing software. When you have a huge amount of code, if you don't have some way to navigate that mentally and say, OK, I'm not going to think about all 10,000 lines right now. I'm going to think about these 300 lines, and I'm going to read them twice and understand them, and then I'm going to make my modification. If you don't have some way to narrow down like that and narrow the scope of what you're looking at and what you're thinking about, you can never really reason about the software effectively once it's beyond a certain size. It just doesn't fit in your head. So OpenStack is actually a great example of this. OpenStack is a very large project. It has a huge number of engineering teams and individuals contributing to it. And it moves pretty quickly. They have new features in every release. But if you needed to understand every piece of OpenStack to go and modify OpenStack, you wouldn't be able to do that. They wouldn't be able to keep up this velocity. So they have a nice architecture here. It's broken down into object storage and network and different components. So if a company is putting some engineering effort into building a new object storage plugin for OpenStack, they really only need to know about that component. And they need to know how it talks to the other components. But anything in the network zone, they can pretty much ignore. So this is already kind of a roadmap to thinking about that software. And it really has to do with approachability. So if I make a change to this piece of code, that architecture, if you understand that architecture, you should be able to figure out what's going to happen, what is the effect, and what won't happen. It also guides newcomers to the code to figure out where do you start reading. If I found a bug in the way that Puppet again behaves, for example, how would I find out what Puppet file to look in to solve that, or maybe what 2 or 3 Puppet files I need to be familiar with to find that bug, rather than just there's 100 or 200 of them, start reading at the beginning. So one of the approaches we take to this, and Puppet again is called our top-level hierarchy. So we organize all of our nodes into a hierarchy of types. And the top level of that is called top-level base. This is all in a single module called top-level. And top-level base includes the things we want on every machine. So these are security concerns, security tools, and things like that, as well as setting up the root account. So we put in the right SSH keys, things like that. Then we inherit from top-level base in top-level server and add characteristics specific to servers. And within our architecture, like I said, we have a lot of build and test machines that are known as slaves. And those reboot after every job. So we have this dichotomy between servers that run all the time, like normal computers, and slaves that reboot all the time. And on the slaves, we run Puppet at boot. So that they come up, they run Puppet before anything else starts, and we make sure that the machine is as desired, the configuration is as desired. The server runs Puppet periodically through cron. And then we specialize the servers further down into specific roles. So the example here is a Mozpool server. And you see that we're nesting we're inheriting classes, but we're also nesting the class names. So you can kind of see the inheritance hierarchy in the name of the top-level class. And in a node definition, this makes our node definitions very simple. They're almost all 3 lines here, and one of those is a brace. The name of the host, and then the top-level class that host is assigned to. And we use regular expressions here as well. But this makes it very easy both to go from host name down to what is this host doing, which is the important direction for some people who are coming to this system, but also to go the other way. It's very easy to take a class and find out what top-level classes is that particular class included in. So for example, if you were looking for where BMM, one of the classes for Mozpool, if you're looking for where that gets used, well, you can see through a simple grep of the source code, that shows up in the top-level server Mozpool. So now you know which machines, based on the nodes, which machines that's going to affect. And if you want to make a change, those are the machines you probably want to be testing that out on. So a second example of this is in configuration. So one of the neat things about Puppet, again, is it's intended to be used. It's a piece of software that's intended to be used in multiple places. So this is done by what we call organizations. And each of those organizations needs to have some kind of knobs to twiddle. So the release engineering team, we want pretty much all the features because we wrote most of them. That's why they're there. But other organizations like SeaMonkey, for example, don't need a lot of those features. They're a much smaller organization. They don't need monitoring. They don't use Graphite, things like that. And we also have a lot of host names to specify. So we specify an NTP server internally. Other organizations may want to use a local NTP server. And we want that configuration to be centralized somewhere where you know where all the knobs are. These are all the things that I can adjust. So you can go there to find out what the settings are for a particular organization, or you can go there to find out what settings you might need to change for your organization. We don't want it scattered among all of the modules, and we don't want to hide it in Hira where it can be difficult to find in version control. So this is a very simple, in terms of the Puppet code here that I'm showing you, this is nothing at all complicated. But we have a very simple approach here of defining a config : base class that lists all of the configuration variables along with comments that you can change and tells you what you would want to change this to and why you would want to change it. And that's in the config module. Then each organization has a config file assigned to that organization. So this is Moco config. Moco is the organization name for release engineering, that inherits from base and then overrides any variables that it wants. This is super simple. I mean, this is nothing you wouldn't think of otherwise. This was also, I need to note, done before Hira. Hira is probably a better solution to this at this point, but we already have this. We actually like it quite a lot, so there's no real plans to change there. So when you're using this within a module, when you need these configuration variables, you just include :config, which is mostly for show to say I'm using this module, this class. And then you refer to the class variables. So config : NTP server. And we would go ahead and insert that into the NTP configurations. So this is another place where I tend to get funny looks. I can't actually see any of your faces, but I'm sure you're looking at me funny. This NTP module isn't generic now. This NTP module doesn't work without this weird config hierarchy that we have that's not even that complicated. But we can't upload this NTP module to the Forge. It would be useless to you without writing a duplicate config module to ours. But I would assert that that's OK. That's a controlled interdependency between some modules in this software. And this happens all the time. We can look at Puppet itself, the Ruby code that is Puppet. There's lots of modules in there. There's lots of classes in there. But for example, the Puppet provider class, or module, I should say, that's great. It's a very important part of Puppet. But we're not going to upload that as a separate gem. It's not useful outside of Puppet. And so it's OK to have modules and use modules to structure your code. But you don't have to think of each module as standing strictly on its own. It's OK to make interdependencies if you make that choice. That's why I say controlled interdependencies. Another good example of these controlled interdependencies is Apache. So if you've used Apache, you certainly know about its modules, mod rewrite, mod PHP, mod passenger. It's pretty much how you do anything interesting with Apache. But none of those modules will run in Lydie or in Nginx or any other web server. They're specific to Apache. So they depend on Apache, but that module architecture is still important to that piece of software. It's critical to Apache's design and Apache's success. So just as another example of this kind of dependency, another very simple thing we do in Puppet again that helps us around a common Puppet problem. So the problem we had is that we put a lot of stuff in /builds. So our slaves put all of their job data under /build/slave. Some of our other modules put things in /build/mozpool, for example. So this /builds directory needs to get created by Puppet, but now you have multiple modules that want to create that root directory. So if you just do that blindly, you end up with duplicate resource conflicts because you're creating that same directory in two places. So we took a real simple solution to that, and that is the DIRs module. And this is, again, nested class names so that you can kind of see what you're reading here. But DIRs :builds creates /builds. DIRs :builds :slave creates builds slave, and it includes the parent directory so that you'll always get that. So this takes advantage of the idempotency of including. We can have lots of modules include DIRs :builds, and it only gets generated once. Again, real simple solution, just taking advantage of one of the language features. But this leads us, we still have that same dependency. This is a controlled dependency between, for example, the Talos module, which depends on this directory, or this module, to create the parent directories to the Talos slave directory that it wants to make. So the third attribute of software that I want to talk about is organizing principles. And this means these aren't so much code and implementation, but they are agreed on ways that we're going to approach problems or ways that we're going to solve particular things that come up. And these are good both for folks who are writing new code or writing patches. They're sort of the tribal knowledge they need to follow to create those. But if everyone knows them who's reading the code, it can also be useful for someone who's reading, because they can make assumptions that everyone else has followed this principle, and it keeps their cognitive load down. So one of these in Puppet, again, is the principle of least surprise. So this is a real simple line. It just says include mig agent install. And you can probably guess, even without knowing what mig agent is, it's cool, you should check it out, what that's going to do. It's going to install mig agent, right? That's what it says on the tin, to use that phrase. Well, in Puppet, again, it's going to do that or it's going to die trying. So there's no case where you can write include mig agent install and have it not install mig agent. And this sounds really simple, but it's tempting when things only work on certain operating systems. And as in this example, mig doesn't work on OS X yet. And it's really tempting when you're writing these Puppet manifests to say, well, you know what, just don't worry about that. We'll just make it silently not do anything on OS X. And when I get time, I'll come back and I'll make it work on OS X. But then folks who are reading this code later, they look at this line and they say, well, it says mig agent install, yet mig's not on this system. What's going on? And they have to dig in to the code that implemented that and figure out why it's not there. It adds a little bit of extra cognitive load. It makes people look into code and read a lot more code to figure out what's going on, because essentially it lied to them. It said it was installing it, and then it didn't. So we try not to do that. And it's almost always about operating systems that things end up, that you want to break this principle. So we usually have case statements about operating systems, and we invariably include a default that fails. So when you run that Puppet catalog on an OS X system, it immediately says, nope, no can do. I can't install mig agent here. So you get an error message that just says what's going wrong. You're not fumbling around trying to read code, trying to see, is it installed? Did it end up in a different directory? None of that. So the last bit I want to talk about is abstractions. And these are, I like to describe abstractions as a box that you can put a whole bunch of complexity in, and then the outside of that box looks a lot simpler. So you don't really have to worry about what's inside that box anymore, unless you want to modify what's in there. And Puppet actually has a lot of these itself, the language and the core resources. And package is a good one of them. So this simplifies installing, the example here simplifies installing HTTPD across a whole bunch of systems. In theory, you're specifying only the minimal information you need. This is the package name I want, this is the version I want. Of course, there's other attributes you can use there. And Puppet takes care of all the complexity on the back end of calling the right package manager, giving it the right arguments in the right order, all of that sort of stuff. So in theory, this is the Java goal of write once, run everywhere. But if you've installed Apache with Puppet, you probably know this won't actually work. HTTPD is the name on enterprise Linux-based systems, but it's Apache 2 on Ubuntu and Debian. If you're installing on OS X or Windows, you're going to need to provide a path to a DMG or an MSI. It's complicated. It's actually a lot more complicated than you want it to be. So this is a leaky abstraction. If you want to use the package provider across operating systems, and we do, you end up having to include quite a bit of complexity here because that abstraction is leaky. So we added another abstraction around that package provider. In Puppet, again, this is how you install a package. You include packages, the name of the package. So again, we have a single module that's providing a kind of functionality with a lot of different classes in it that you end up using. So there's I think, about 100 of these now, different packages that you can install. And this is, again, real simple, just like the MIG agent example. This says install that package, and it's going to take care of installing that package. But the outside of the box is nice and simple. And unless you care, you don't have to look inside that box. But here's what's inside that box. So these are the differences I talked about. Different package names. On Darwin, actually, Apache is already installed by default, and we don't really care about the version, so we just use that. We don't need to install a DMG. And then on any other operating system, it will fail. We need to fix this for Windows, but we're getting there. So these were some good examples of what software is. But writing software is hard. I think if you ask software engineers who are doing typical programming, they'll tell you it's hard, and we really don't understand how to do it, and in a way, we're fumbling in the dark. But certainly, writing software that does configuration management and infrastructure is very hard, because it's a new thing. It's very new. So I want to talk a little bit about the challenges we've faced with Puppet again, and some of the things that you need to think about as you're trying to develop software and infrastructure as software. And I want to start with, this has turned out to be kind of the monster that ate Puppet again. Package repositories turn out to be part of the code. So our build and test machines, they all need to be exactly identical. Like, they need to have exactly the same version of exactly the same packages installed on them at all times. And that needs to hold true over a large amount of time. Right? Until we decide to upgrade, we need to have exactly those same package versions. So we can't use upstream Ubuntu or CentOS repositories. We need to have a frozen repository that has specific versions in it. That means those versions, which are in this file repository that's served by HTTPD, those are actually part of the code. That's specifying that configuration, but it's not in our version control. It's nowhere in a Puppet manifest. So pinning seems like the solution to this, right? Pinning is actually really hard. So for one thing, you don't want to pin every version. I think our CentOS systems have about 450 packages. So it's not practical to write a package declaration for each one of those 450 packages, because when that changes, how that changes is very unpredictable and hard to follow. They can also confuse package managers. So we had a problem recently trying to upgrade OpenSSL where apt tried to upgrade OpenSSL to a more recent version than we wanted, and then downgrading it, uninstalled random other packages, but the Puppet run succeeded anyway, and we ended up shipping a whole bunch of machines that didn't have Python installed on them, and Python's kind of critical to our process. So it turns out with OpenSSL, because of this particular interaction with apt, the only way we can deploy an OpenSSL change is to cd into a directory and copy an OpenSSL deb file in there, and that sucks. We don't want that to be the case. So this is sort of the core problem here, is modifying the repo to make production changes is not a way to be building software. Mirroring is also really hard. When we made these frozen mirrors, the idea was we'd upgrade them between Firefox releases. We do a Firefox release every 6 weeks. So we thought, well, 3 weeks in between, that'd be a good time to remirror things. If something goes wrong, we got 3 weeks before a release to figure out what's going on. But it turns out this is high risk, partly because of the pinning problem. And it's really low reward, right? It's hard to make a pitch to the engineers to say, I'm going to do something that might leave a couple of your engineers scrabbling around to try and find a really obscure bug for a week or two. And there's really no benefit to the company. So pretty much every time we've tried to upgrade, there's been more important things going on, and we haven't. So we're still running an old version of CentOS 6.2. We're still running an old version of Ubuntu, largely because I just haven't been able to sell remirroring. Sharing is also hard. So this is an open source project, and ideally you can fork an open source project, go and hack on it, and then send patches back. And to start with, forking in this case means copying quite a bit of repositories locally to your system that aren't in a version control. But more to the point, pushing changes back, we have no way for you to say, I modified these index files or I added these RPMs, other than like sending me an email and saying, I added these RPMs, they're attached, can you put them in the repository? And sending patches in text in an email like that is kind of old school. We don't really do that anymore. They're also huge. 315 gigs of repositories. It's mostly Ubuntu because we need Universe. So this is, asking someone to clone this to a Vagrant VM, you need a lot of disk space. So this makes it difficult for developers within Mozilla or other people who want to use Puppet again to bring up a new system, their own organization, and to start to experiment with it, because you need a lot of disk space and it takes a lot of time. Thus, one of the solutions we're looking at for this is Git Annex, which can handle versioning large files without actually including those large files in the Git repository. So that works to get partway to the solution for some of these, but it's not going to solve all of the problems I just talked about. So we still need to work on that. We're finally realizing that this is actually a problem we need to solve pretty seriously. The next challenge is more of a Puppety thing. Interactions between modules are kind of hard. So the example I want to use here is if you're installing Apache. If you install Apache by default, you want to send your access logs to disk and probably rotate them. Maybe it's not a very important server, and those access logs aren't really important to you. So an example is our build and test slaves actually run Apache locally, so we can test Firefox against them. But I really don't care what the access logs are. They're just test runs. If you have an rsyslog module that's doing some kind of log aggregation, sending to a log aggregator, then maybe when both of those are installed, you want to take those access logs and send them to your log aggregator. So Puppet really doesn't have a way to model this idea of if this is installed and this is installed, or if this class is present and that class is present, then do this third thing. There's a defined function, but it depends on parse order. You really kind of don't want to use that. So the way we've handled this in the past is for one of the classes to basically drop a config file in the config directory for another. So in this case, in this example, the HTTPD class is calling out to rsyslog to create its logging directory, and then dropping an HTTPD-specific configuration file for rsyslog in there. And this is kind of gross, because the HTTPD module has to have pretty detailed knowledge of the rsyslog module here. It has to know about this particular subclass, config_dir. It has to know what an rsyslog config file looks like. And if you've used rsyslog, they don't look good, even the new style. So this is a weird interaction. This is an undesirable dependency between modules. And we'd like to get away from this and have some way of specifying separately that when these two kinds of functionality cross, I want to add this additional functionality. The last bit I want to talk about is testing. So Puppet again doesn't have any tests. And it's 2014. I mean, come on. Typically, we've had a lot of people suggest and even try and do very spec-based testing. But I've kind of resisted that because we're not building very complicated modules. Our spec is really useful in testing complex Puppet functionality. If I give it this input, these conditionals work out so it does this. But if I give it this different input, the conditionals work out so it does this other thing. Most of our modules, or most of our classes, they install 2 or 3 files and they set up a service or something like that. And a spec that says when I include this module, which says file name, mode, user, it creates a file with that file name, mode, and user. That's not a very interesting test. I can pretty much look at the code and say that's correct. The problems that we find in production are much more subtle and obnoxious. The OpenSSL example was one of these. If we'd had an acceptance test which said, when I run Puppet on an Ubuntu node, at the end, Python is installed, we would have caught that error. But we're not going to catch that error with an RSpec test for one particular module or something, because it's not going to even know that something's changed in the repositories. So Alice Nodelman talked about Beaker yesterday. And I think that's going to be a much better model for us to do acceptance testing, basically creating an instance of each top-level class, running it through Puppet until it succeeds, and then making various assertions on it. And going back to the repositories, this can even get us to the point where we're managing those frozen repositories correctly. So we can assert about all 450 of those packages that are installed on our CentOS nodes. They won't necessarily be in our Puppet manifests, but we can assert on them, and when we upgrade, we'll know exactly which of those versions have changed. We can evaluate that with the developers, look at the relative risk, and maybe pin some of those if we decide that that's too high of a risk. So that's it for the challenges that we're facing. Well, there's certainly more, but those are the three I wanted to talk about. But like I said, this talk, I want you to try and think about leveling up what you're doing in Puppet. And instead of thinking about Puppet configs, I even heard a couple of the speakers talk about Puppet configs. Puppet isn't a configuration language. Puppet is a programming language. Think about what you're doing as programming, and think about what you're doing as software development and not just writing scripts. And take a little bit of time and a little bit of effort with your team to build some structures, some architectural abstractions, all of these things I talked about. Fit those into your Puppet infrastructure, and I think you'll find that you can move a lot farther. You can get a lot more configuration handled by your Puppet without increasing your cognitive load, without having a hard time onboarding new people into your Puppet environment if it's structured as software. And if it's at all possible, open source your Puppet stuff. Not just a couple modules, but your whole thing. I know that's well nigh impossible for most of the people in here. But it is a little frustrating to come to PuppetConf and talk about how people are using Puppet, and they'll open their laptop and kind of turn away from you because it's proprietary, right? Maybe it has passwords in it, maybe it's just proprietary information. But if a lot more of us could share, oh, okay, my corporate stuff, it's up on our GitHub account, here's the URL. And I can go and look at your manifest and see how that works. That can help us converse. It also helps people learn how to write Puppet code. So Liz mentioned this in her talk too. This is a great way to learn how to write Puppet, is to see an entire Puppet install and not just one module, and start to learn about some of these interactions between modules as a newcomer to Puppet. So that's all I have to say. I'm happy to take questions both about writing software in Puppet and things like that, and also about Puppet Again, because I think Puppet Again is pretty cool. So again, please check that out, and if there's something that sort of caught your eye here, I'd love to hear about it. And look, you even have a microphone.
I noticed that you're ensuring latest for the packages. Can you ensure a specific version and then just change the version when you roll up?
Yes, so that's what I was referring to as pinning. And I think the example you were looking at that ensured latest was with the Apache install. So we don't ensure specific versions for everything because in many cases we don't care. So our Apache usage is just serving static files for our performance tests. So pretty much like Apache 1.0 through whatever the latest is works great for that. So we don't care what that version is. But most of our package definitions do specify a very specific version. Other questions? No? Surely someone's wondering something. Yeah, go ahead.
About the example you provided with interdependencies with HTTPD and our syslog. It seems as, and then you showed some code where the HTTPD module was actually, interrogating to find out if our syslog was involved. It seems to me like you presented that as being a problem. Is that the solution to the problem you presented, or are you saying there is no solution to this problem in the world we're living in?
The second one. So this is a way to accomplish what we wanted with Apache dropping this config file. And it's not so much that Apache is interrogating syslog as Apache is dropping a config file. And if our syslog isn't installed, that's just a text file on disk and it never gets read. So this gets us the behavior we want, which is that when they're both installed, something interesting happens. But I think it's a really messy and gross way to do it because there's this weird interaction between these unrelated services.
So you talked about Beaker, that you can use it to verify different things, but I think it's mostly used for like testing. When you have a test environment, like is there a way for Puppet to verify that it did what you wanted to do in production without like security issues and stuff that Beaker has has to SSH password list to a node and stuff.
Right, yeah, the SSH issue worried me a little bit, and this question came up in Alice's talk. We do manage SSHD and certainly make sure that there are no passwordless SSH keys in root's authorized hosts. So that may take a little bit of hacking, but I think if we were using Beaker, we would be doing it in an isolated environment. So the security issues, assuming we can get that passwordless login working, the security issues wouldn't pose any threat to production. It'd be using temporary or testing only secrets. We segregate all of our secrets off in a corner, and you can replace those really easily. So it wouldn't have production secrets. It wouldn't have any network access to our production systems. So security issues around Beaker don't really worry me. But you're right that sort of making that a realistic production environment in terms of testing, that can be a little bit difficult. And I've only had about 24 hours to think about it, so I may have more problems than I know. Mm-hmm. Right.
You could run them on the local machine if you want to.
Yeah. So he's pointing out that Beaker is responsible. Well, that server spec is the test framework that's going on that's used commonly with Beaker. I think you can use another one if you want. Server spec is the one that's saying, on this host, verify this service is running, or on this host, verify this package is installed. And Beaker provides you the automation to create new instances of a particular type and connect masters and slaves and things like that. So we do quite a bit of stuff in AWS right now. We have a hybrid architecture between a data center and AWS. So I think we'd end up using Beaker to create AWS instances that are isolated, and we'd be writing server spec to assert particular packages that are installed and to make the other kind of policies that we need to make sure are in place so that our developers are happy. Anything else? Yep. Okay.
So I've got kind of two questions. One kind of leads to the other. So do you see this behavior of including cross-modularly? Do you see that as kind of going against the grain? Do you see problems when you try and submit your modules to Puppet Forge with that?
Yes. But not all of these modules belong on Puppet Forge.
Right.
So actually, the NTP example that I used is a good one here. I think that was in this example. Well, yeah, there we are. So this is the NTP module that I actually mentioned. This won't work on the Forge because you'd have to have this weird config thing that we have in Puppet again. But that NTP module is unique in a couple other ways, and one of them is that, as I mentioned, the build slaves reboot after every run. So running NTPD on a machine that reboots every hour isn't that useful, because NTPD just gets it slewing up to get the clock fixed, and then it reboots and everything starts over. So our NTP module is specifically configured so that on machines which reboot all the time, it runs NTP date at startup, and it blocks until that's complete. And then on servers, it runs periodically with NTPD. So this is a case where it doesn't really matter that this module has these weird interdependencies, because it's not particularly useful outside of Puppet again anyway. And this is common among all kinds of software, that you're going to write modules that they're nicely modularized inside the piece of software, but they're not so independent and unique and generally useful that they're useful outside of that piece of software. It's actually a rare and beautiful moment when you write a nice utility function or class or something like that in a Python application. You say, wait a minute, this thing's pretty cool. I'm going to pull this out, make it a separate project, and upload it. It does happen, but not very often.
Okay.
Do you have a second question?
Yeah. And so, like, just coming again from the perspective of abstraction, do you feel like the DSL and Puppet and the inheritance mechanisms that are available, do you feel like maybe they're a little bit limiting in terms of how you can use Puppet? Do you feel like we could push the envelope a little bit with that?
Yeah. I have 26 seconds. So I can certainly say a lot about the language.
Yeah.
Like I said, I'm really
not to say anything
Yeah.
bad about Puppet, but I mean, do you feel like there's room for improvement there?
Absolutely, there's room for it, and I think that the work in Puppet 4 and the future parser is laying the groundwork for that. there's a lot of improvements that could be made in terms of finding bunching common resources together, package resources, for example. Yeah, I could go on for quite a while thinking of examples, but certainly I think we're on the path to improving that, but there's a lot of room for improvement in how the language works. So. All right. Well, thank you very much.